Okay, in this video, we want to consider the equation x squared plus y squared minus 2x minus 6y plus 5 equals 0. And we want to solve it for dy dx, and we also want to find the second derivative, and then we want to evaluate each one of these at the point where x equals 3 and y equals 2. Using the method of implicit differentiation. So, let's go along and get started here. This would be 2x dx, which is just 1, plus 2 times y dy dx minus 2 times dx minus, which is just 1, minus 6, this would be dy dx, and we take our derivative. And the derivative of that constant, of course, is 0, and that equals, and 0, of course, is just a constant, so its derivative is 0. And it looks like we can divide by 2. So this will be 1, this will be 1, this will be 1, and this will be 3. So let's see what we have. We have dy dx and it's times y minus 3. And we have plus x minus 1 equals 0. So let's see, we're going to bring this and this over to the other side of the equation. So that's going to be 1 minus x. And divide by this. And that should equal then dy dx, 1 minus x over y minus 3. And let's see, if we put our values in here, x equals 3, so we have 1 minus 3, divided by y equals 2, we have 2 minus 3. This equals negative 2 divided by negative 1 equals 2. So here's the general equation for dy dx, and at this point here it's going to have a value of 2. Now we want to find a formula for the second derivative. And d squared y dx squared, that's the same thing as taking the derivative of this with respect to x of dy dx, and that's the same thing as taking the derivative of this with respect to x. So 1 minus x divided by y minus 3. And we want to take the derivative of this 1 minus x in the numerator, y minus 3 in the denominator, and take the derivative of this with respect to x. And remember how it goes now when we have these quotients here. We're going to have this times the derivative of this times the derivative of this, minus this times the derivative of this. Everything is divided by this squared. So let's write it all down here. We have this, y minus 3, minus the derivative, or times the derivative of this quantity with respect to x. course, that's going to be 0. And then we have minus dx dx. That's just minus 1. So we have a minus sign out here. This times the derivative of this minus this times the derivative of y minus 3. And the derivative of y minus 3 is just going to be dy dx. The derivative of that, of course, is 0, and we have dy dx. That's the only part of this expression that will not be 0. And then the whole thing is divided by y minus 3 quantity squared. Let's check ourselves. To find the derivative of this quotient here, it is y minus 3 times the derivative of this quantity with respect to x. Because that's going to be 0, so it's going to have minus dx dx, which is negative 1. Then we have minus this quantity times the derivative of this expression taken with respect to x. So then we're going to have dy dx, and of course that's a constant, so that's going to be 0, and the whole thing is divided by y minus 3 squared. Now, here then we have 1 minus x times dy dx. We know what that is. That's this. So before we plug this into here, so we don't get confused, let's divide this. Let's split this into two parts here. So this expression here will equal y minus 3 divided by y minus 3 squared. That's going to be minus 1 divided by y minus 3. That comes from this. Then we have minus 1 minus x divided by y minus 3 squared. Let's get this into viewing here. Here we took this and divided it by this. So that's minus 1 over y minus 3. Then we have minus this part, this divided by this, and minus x divided by y minus 3 squared. Now we have times dy dx. And that's this. So we have times 1 minus x divided by y minus 3. And this will equal minus 1 over y minus 3 minus 1 minus x quantity squared divided by y minus 3, and that's going to be cubed. Okay, and that's d squared y dx squared, our second derivative. It's in two parts here because of what we did back here, and we did that so that when we put the value in here for dy dx, we won't get confused. But let's go ahead and put all this under one denominator again. So this would be this times this, so that will equal minus this times this minus y minus 3 cubed minus this times this. It's minus, we have a minus sign here, so we have y minus 3 times 1 minus x quantity squared divided by y minus 3 to the fourth. And of course we could simplify this. This would be minus, dividing through by these, that would be y minus 3 squared minus 1 minus x squared quantity squared divided by y minus 3 cubed. And that then is our expression for d squared y dx squared. That equals minus y minus 3 quantity squared subtract 1 minus x quantity squared divided by y minus 3 quantity cubed. And that's the expression then for the second derivative. For this equation here. This equation here has this for its second derivative. And we want to evaluate this when x equals 3 and y is equal to 2. So let's see, if we have y equals 2, 2 minus 3 is negative 1, squared is positive 1 with a negative sign by it. So we're going to have negative 1, this part here comes out as negative 1, minus 1 minus x. X is 3. 1 minus 3 is negative 2, squared is plus 4. And down here, y is equal to 2. 2 minus 3 is negative 1 cubed. That's negative 1. So here, this would be negative 1 minus 4. That's negative 1 plus negative 4. That's negative 5 divided by negative 1. So at this point here, the second derivative is 5. So that's it. That takes care of it for this problem. And again, you see, here is our equation, and it turns out that finding the second derivative of that is kind of a complicated expression. But if we go ahead and just use the same old differentiation rules that we've been using all along, really it's not difficult to get that expression. And again, that kind of shows you how very convenient it can be to use this technique of implicit differentiation. So that's it. Come back and join us for some more videos, and we'll see if we can solve some more problems.